This is page 4 of Chapter 7 review worksheet. Problem number 15. Both the lower and the upper limits are infinity, negative infinity, and infinity. So I'm going to split it up as two parts on this. So I have the limit, and then the lower limit I'll just say as a approaches negative infinity. And then it's a, and I'm going to choose a middle number of a 0. And 0 is going to be fine in this case because it's not going to produce a vertical asymptote anywhere here. And anyways, on this, there's no vertical asymptote. So that's this first part. And then plus the limit as b approaches infinity, and whatever number I choose here has to be consistent with this one here. So I'm choosing 0 as my lower bound, and then my upper bound is b, and then of this function. All right, then I'm going to do a u sub. So let's let u equal a negative x squared. Du is equal to negative 2x dx. So the negative 1/2 du is equal to x dx. So if I calculate that integral, I have a negative 1/2, and then integral of e to the u du. And then integrating that, I have a negative 1/2 e to the negative x squared. Okay, so I'm going to put that in for each of these two integrals and then evaluate them. So you have a negative 1/2 e to the negative x squared going from a to 0. I'm going to pull out a negative 1/2, and then when I put in 0, it's going to be e to the 0 power, which is just 1. And then when I put in a, it'll be minus e raised to the negative a squared. So if I'm going out to infinity, then this is going to come out to be e to the negative infinity, which is same thing as 1 over e to the infinity, which is 0. So in this portion here, I get an answer of a negative 1/2. So this converges. So in order for the entire integral to converge, that means that both parts of it has to converge. So now I'm going to test out the second one. I'm going to put in or factor out a negative 1/2, and then my upper bound is b, so it's e raised to the negative b squared. And then when I put in infinity, that goes to 0 because it's 1 over e to the infinity. And then minus e to the 0 power, which is 1. So here I get a negative 1/2 times a negative 1, which comes out to a positive 1/2. So adding them together, I get 0. So since both of them converge, the overall integral converges. However, if one of them diverges, then the entire integral will diverge. Okay, number 16, I'm going to make my lower bound as limit as a approaches negative infinity. So I have a integral of a out to 0 of e to the 7x dx. So I take that integral and I get 1/7 e to the 7x, and it's going from a to 0. So you have 1/7 that get factored out, and then in the upper bound it's going to be e to the 0, which is 1 minus e to the 7a. So if 1 is just going to stay as 1, and then for e to the 7, and then you're going to put in a very small or large negative number. So this part here is just going to go to 0. So for example, if I put in like negative 100, it would be e to the negative 700, which is 1 over e to the 700, which is very, very close to 0. And so my overall answer is negative 7, 1/7 times 1, so it's 1/7. And since the limit exists, the integral converges. (17) Find the volume of the solid that results when the region is enclosed by y is equal to sine x, y is equal to cosine x is equal to pi over 4, and x is equal to pi over 2, and revolves around the x-axis. So I'm going to draw out my sine graph. So this purple one is my sine graph, and then the blue one is my cosine graph. And we know that they intersect at pi over 4, so that's going to be my left limit, and then it's going out to pi over 2. Okay, so this pink region that I've shaded in, that's what is going to be revolving around the x-axis. So I'm going to call from here to here is my capital R, and that is my sine graph. And then from here to here, which is the whole, is r, small r, so that's the cosine graph. So I use my general formula of volume is equal to factor out of pi, and then integral of pi over 4 out to pi over 2, capital R squared minus small r squared dx. And then I'm just going to substitute it back in. So you get sine squared x minus cosine squared x dx. So I'm going to rewrite sine squared x as 1 minus cosine of 2x over 2. And then cosine squared x is 1 plus cosine 2x over 2. And then if I do some simplifying here, I have 1/2 and then minus a half. So that basically just cancels out. And then I end up with a negative cosine of 2x, and then over 2 minus cosine of 2x over 2. So I have a 1 that's negative 1 that can get factored out. All right, so that's why this becomes a negative pi. And then the integrand is cosine of 2x. Okay, so I integrate that and I get cosine of 2x is negative 1/2, and then multiply that by pi and sine of 2x. And then I'm going to integrate it from pi over 4 to pi over 2. So I'll factor out a negative pi over 2. And then when I put in pi over 2 in for x, I get sine of pi minus sine of pi over 2. So sine of pi is a negative 1, and sine of pi over 2 is 0. So I get negative pi over 2 times a negative 1, and they're both negative. So the overall answer is pi over 2.